Alright, 810, destructive testing. The procedure for the qualifying testing, welding, development, work metallographic specimens are sometimes removed from the structure to check for the quality of the weldment. The tests are used to determine the visibility of the characteristics of the weld. Metallographic testing samples are sectioned with the cut through the weld and desired displaying with the polished edge of the reveal of the structure of the specimen. It may examine the name naked eye with the various magnification, including microscope. Among the characteristics they may can be checked for their sound, dislocation, depth of the penetration of the weld, metallurgic structure of the weld, fusion zone, heated, affected zone, the extent of the distribution, undesirable inclusion within the weld, the hardness, the gradients, the number of the weld passes. Metallographic specimens are removed. Any part of the structure repairs must be made by qualified welders and welding operators using accepted welding procedure. Painting and heating the treating may be required to develop the full strength of the members cut and to relieve the residual stress. Test method. There are three categories for the destructive test method: chemical, hardness, and mechanical testing. Chemical testings are generally used to validate the chemical composition, corrosion resistance of the base of the weld metal, the particular composition of the metal involved. Example: the examined conformity of the specification in addition with the chemical analysis of the welded metal can show whether the welding produced the expected result, whether it was introduced undesirable constitute into the width of the metal emit into the welded metal, corrosion of the test, and demonstrate the weldment capability to withstand the corrosive environmental encountered with the surface. Because of the cost and time involved, the weldment usually cannot be tested for corrosion resistance by actual use under the surface conditions. Therefore, accelerated corrosion tests that can be conducted under laboratory conditions have been developed. 2. Hardness tests. Hardness tests measure the resistance of the material to wear for the most of the material metal ductility conversion. Corrosion resistance decrease as the hardness increases. Since each of the operation during the welding is metallurgical effects, some of the specifications call for the upper limit of the acceptable hardness of the various areas of the weld. Hardness testing is done with equipment which is under the specified load for a small-handed hardened steel ball with a diamond point within the surface of the metal. The depth of the penetration is either measured directly by the machine or inferred with the dimension of the impression by the associated number of each of which with possible impression depth. The inspector can develop the hardness scale with the testing approaches used. The three most common hardness measuring devices: the Brinell, Rockwell, Vickers hardness tester, and the hardness numbers may vary from the method because of the difference in the formulas used to define the hardness numbers and material type, the shape used to make the impression and then imposed with the load. However, the table is approximately equivalent hardness number that have been constructed. Mechanical tests are exclusive of the hardness. They have been designed to test several weld properties. Tensile tests that are conducted with specimens to machine for the test of the weld. They are used to measure the strength of the weld. The joint and the specimens are usually taken perpendicular to the weld, which is the center of the specimen. However, the specimens are sometimes taken along the weld consistently entirely weld metal. Specimens may have round with rectangular cross-section depending on the requirements of the applicable welding code. The testing machine. Alright, A shows the rectangular specimen. B sends a cylindrical specimen. Applies the tensile force of the specimen, ruptures the reading with the machine, the measurement of the specimen before and after the test, properties of the yield point with the yield strength, the ultimate strength of the ductility are calculated. The primary purpose of the test is to demonstrate that the weld is deposited for the selected procedure meets the exceeding minimal values specified in the applicable code of the specification. Guide bends tend to be include the welding ductility and testing specimen describe the root of the bend, face bend, side bend, depending on the surface of the stretch and bend. The rectangular test specimen, similar to those prepared with the tensile test, are machine ground to remove any of the welding reference of the test jig as shown in figure 8.15 is used to make this bend with the plunger removed. The specimen is placed across the shoulder of the jig and with the welded center with the plug is then forced down until the specimen is bent into a U shape. The elongation of the tension surface determines the relationship between the thickness of the specimen and the radius of the die. The specimen falls if it has a crack other than open defects greater than the specified number and size if it is fractures. Free bend test also ductility used the specimen similar to those guided with the bend test. Before the test guide engaged lines inscribed across the width of the sample the deposited welded metal. The lines mark off the distance about 1/8 of an inch less than the width of the weld. The sample to give them the initial bend. Figure 8.16 is the supporting end of the shoulders rollers, then forcing the center down until the specimen takes permanent set. Next to a testing machine device, figure 8.16 used the compressor of the sample longitudinal until the crack of depression appears on the convex face of the specimen. Until the specimen is bent double, the load is removed immediately and the defect appears between the specimen and bent double. The percent elongation calculation for the initial final distance between the gauge of the marks. Shear tests or fillet welds are conducted with the whole specimen apart with the testing machine. The dimensions of the specimens make it easy to use. This shows the figure 8.15, the guide bend test, the die member, the plunger member. Test results obtained the shear strength of the pounds per inch of the weld. Figure of 817 showed that the shear test of the specimen indicates where the machine specimens from the test weldment. A nickel brake test is required for the sum of the welding code to detect the weld defects. The nickel brake test specimen similar to the rectangular tensile test specimen, except the notches are cut and out of the center of the weld. The specimen is then broken either by pulling in the tension of the bend or by bending it. The specimen is forced to break in the weld metal because of the notches. After the specimen has been broken, the fracture surfaces are examined for the weld metal defects. If there are more than minimum allowed, the weld is rejected. Various types of impact tests are sometimes used in tests of fracture toughness. The weld metal material, low end alloy, high strength steels are being welded. For these test measures are the weld metal compatibility resists crack propagation under low stress. Sampling techniques: removal of the sample to section is accepted method. Welding inspection proved the various pressure vessels because of the cavity must be later than be repaired by rewelding. Method is sometimes considered a destructive test. Samples may be taken with a chemical analysis, etc. Tests, subsize, tension, or impact tests. The specific method of removing the sample depends on the size of the specimen needed. Hole saw, bolt cutters, and cold chisel or tree panning tools. Special power tools with a hemicervical saw are often used. The sample removal. The sample must be carefully selected to represent the weld of the base metal being checked. Alright, your initial set, your compression of specimen, figure 817. Alright, this shows the throat and the specified set of the field wet of 1/8 of an inch, 4 and 4/45 inch to the throat dimension. Figure 817 transversal fillet weld shear specimen. Alright, 811, leak test. Leak tests are similar to proof test of the closed pressure vessel, the container being the test of the filled with the fluid. The specified pressure of the shows the liquid gas dependent on the purpose of the container. The leakage of the can be tolerated. For example, the containers that are watertight may be not oil-tight, and the gas-tight leakage can be detected in several ways. For the oil-water visual inspection of the outside of the pressure valve may suffice. Leakage of air or gas can be detected by the sound of the escaping gas by using the soap of the film that forms bubbles or gas escapes beneath it. By immersion in liquid in which the escaping gas forms bubbles, hydrostatic or gas test. Pressure gauge attached to the vessel indicate the leak of the by drop the pressure after the test is beginning. Dyes introduced into the liquid, tracers introduced into the gases can also be indicated. Leakage. Weld defects that cause leakage are not always detected by usual non-destructive testing methods. A tight crank or fissure may not appear with the radiographic yet will form a leak path. The production operation such as the forming of the proof test may be leak of the development into otherwise acceptable welded joint. A leak test is usually done on the completed vessel. If all the welded joints can be inspected at the same time, at this stage there will be no more fabrication operations after the inspection. Inspection is easier if the vessel is empty. The most common type of leakage testing are discussed below. Your pressurized test method is used to see whether any of the leaks exist and test the part being inspected with the attached to the vacuum pump. They have evacuated the pressure of the 0.5 psi absolute when the pressure is reached with the connection with the vacuum pump. They're sealed off. The internal pressure of the part is measured immediately. The pressure is measured again after at least 5 minutes within the item that's still sealed off with the vacuum pump. The issued pressure of the evacuated space remains essentially constant with the welds that are free of the leak. And if there is any pressurized, the leak of the one leak is present, and the helium leak the test describes in below must be used. Alright, the helium leak test is more precise when the precise than the pressurized method is used to find the exact location of these leaks. Helium leak testing is slowly, however, so normally is not used to inspect large items unless the leak definitely exists. The inspection method requires the use of a helium mass spectrum detector presence of the helium gas. The mass spectrum connected with the pumping system between the vacuum pump and item. Beginning with the inspection, the item is evacuated by the vacuum pump to the pressure less than 500 microns of mercury. The mass spectrum can detect the helium that evacuated space. Small jet of the helium gas is directed to the side of the weld joint exposed with the atmosphere. This is leak. If there's some leakage, some of the helium is struck through into the evacuated space. The mass spectrum and immediately indicate the presence of the helium. Of course, there is no leak. If there is no leak present, no helium will enter the evacuated space. No indication will appear on the mass spectrum. To determine if the exact location of the leaks, the jet of the helium is moved along the surface of the welded joint. At the same time, the inspector carefully watches the mass spectrum meter. If there is an indication the leak is at the point where the helium is in hitting the surface of the welding joint. C. To detect techniques for the ultrasonic translator detector uses the ultrasonic sound of the gas molecules escaping the vessel under the pressure of the vacuum and sound created with the frequency range of 3500 to 4500 Hz, which is above the range of human hearing, is therefore classified as ultrasonic. Certain characteristics, those as frequently as useful detection, they are outside of the range of the most plant machine noise and other short wavelength frequencies permit those use of the high directional microphones. Any system or vessel that can be pressurized evacuated to a pressure of 3 psi can be inspected. The operator simply listens to translated ultrasonic sounds while moving a handheld probe along the weld in the same way the flashlight is used to illuminate suspected leak locations. The detectors are simply to operate require minimum operator training. D. Some of the following tests, particularly with the air soap solution test, can be conducted on a vessel during and after assembly. Inspector can locate the large defects in order to reduce the time needed for the final leaking test. After the testing, vessel should be thoroughly cleaned to remove all the traces of the soap solution. Hydrostatic test. The test should be conformed with the applicable requirements of the particular vessel of the system on distilled deionized, demineralized water having pH of 6 to 8 and an impurity content no greater than 5 ppm is used. The trace of the water should be removed from the inside before the line of leak testing is begun. Water submersion test. If the test of the vessel is completely submerged in clean water, the interior is pressurized with the gas, but the design pressure must not be exceeded. The size of the number of any gas bubbles indicating the size of the leaks. Soap solution test. In the test, the vessel is subjected to internal gas. The pressure not exceeding the design pressure of soap or equivalent solution is applies so that the connection of the welding joints can be examined for leaks. The air ammonia test. The test involved the introducing air into the vessel, so that the present design procedure is needed. The anhydrous ammonia is introduced into the vessel until 55% of the design pressure is reached, and air to the reintroduction until the design pressure is reached. Each of the joints is carefully examined by using the probe, either in a swab welted to the 10N solution, muriatic acid, or hydrogen chlorine, sulfuric candle, or sulfur dioxide wisp of the white smoke indication of the leak. Alright, your halide torch test. The test for the vessel is pressurized valve not exceeding the design pressure. A mixture of 70 of SO. The percentage of freon and carbon dioxide, 50% of freon nitrogen is used. Each joint is carefully probed with a halide torch to detect the leaks, which indicate the change in the color of the flame. In 6, halogen sniffer test, the freon in and air gas mixture is introduced to the vessel until the design pressure is reached. About 1 ounce of freon is formed every 30 cubic feet of the vessel volume is required. The inspector passes the probe of the halogen vapor analyzer over the area to be explored with the probe at the hole within 1/4 inch of the surface being tested and moved about 1/2 inch per second. Since the instrument is responsive to the cigarette smoke and vapor from newly dry cleaned clothing, the air should be kept clean while the testing is being done. In addition, the testing should be done in a substantially draft-free enclosure. And that completes Chapter 8.